That's it. Yeah. Shivaram? Yeah.
This is the powerhouse where the foremost innovators and entrepreneurs of the country team up with the smartest talent pool of students and faculty from IITM. The Research Park plays a catalyst that fuels unrestrained networking for future growth and business success while solving globally relevant problems. Space plays a vital role for business communities in shaping company culture. In the landscape of a thriving economy, the Research Park is located in the heart of the Tech Corridor in Chennai, lending homegrown expertise for global solutions. IIT Madras Research Park, the future of cutting-edge research and development.
So the bioincubators have been formed with the idea of providing a platform to startup companies in biotechnology, whereby they can have access to wet lab facilities, be it facilities for molecular biology, bioprocessing or analytics, things that they can't normally afford with the startup funds that they have. We have one.
So thank you for the video, Shivram. Greetings to everyone who is present here on this lovely evening. It's a great honor in inviting everyone to this webinar. We are happy to announce the 18th webinar of this IRIS webinar series, Connected Intelligent Urban Transportation under the cluster Big Networks. So today in the session, we have Dr. Geeta Krishnan Ramadurai as the speaker and Dr. Dasi as the moderator of today's webinar. So to say a few words about Dr. Geeta Krishnan. So Dr. Geeta Krishnan Ramadurai is an associate professor in the Transportation Engineering Division, Department of Civil Engineering, IIT Madras. His overarching goal is to develop technological and management solutions for a safe and sustainable transportation system. So his primary research interests are network modeling, dynamic traffic simulation and assignment, intelligent transport systems, vehicular emissions, urban freight, public transit systems, and road safety. So, and to say a few words about our moderator, Professor Dasi Bullock. So Professor Dasi is the Lilas Family Professor of civil engineering at the Purdue University, and serves as the director of the Joint Transportation Research Program, which is called as JTRP. Bullock is registered professional engineer in Indiana and has 30 years of experience in the industry, working closely with the airports, transportation agencies, and the automotive industry, the private sector partners. And also, he is currently leading several projects related to connected and autonomous vehicles and probe vehicle analytics. And also, we have our special invitees and with the panelists from the Civil Engineering Department, IIT Madras. We welcome Dr. Atul Narayanan, Dr. Surendra Singh, Dr. Lalita Devi, Dr. Bhargav Chilukri, and also we have Dr. Karthik K. Srinivasan. So without taking much time, I hand over the session to Dr. Darcy. Doctor, the virtual floor is all yours.
Well, I don't really have much to say for opening. I think Dr. Gita is the star attraction, so I'm excited to hear his briefing on the work that's going on there. And I guess I just want to thank everybody on the call. Lalitha started off this partnership, gosh, Lalitha, is probably almost 15 years ago. And we've had several good interactions, exchange of students, and I look forward to this webinar continuing that. So I will pass the virtual webinar baton over to Dr. Gita.
Thank you so much, Darcy. Yes, so of course I'm presenting this on behalf of my entire team here. So it gives me great pleasure, and it's a privilege to be presenting about a new lab that we're setting up here at IIT Madras. So this is going to be on connected intelligent urban transportation. And we see this as a continuation of what we've been doing earlier, which was the Intelligent Transport Systems Lab and the Center of Excellence in Urban Transportation. So this is part of the Big Networks cluster. And before I get started, I just thought I would motivate, why do we need all this connected intelligent transportation systems, right? We have been traveling on our roads, especially in India. We often complain about how inefficient the traffic lights are, right? Most of the time, anytime we are traveling, we get stuck in just about every red light, right? How many of you have experienced this? And every time we get stuck in this traffic light, we say, I wish I could just drive through without stopping at a traffic light, right? Another example that perhaps we all can relate to is running to catch the bus. Maybe you caught the bus, but then you have to make a change to get to another bus and then get off to get to your workplace, right? Wouldn't it be much more easier if you just had a cab on call, which you can get at any time? And maybe you had some extra time to spare so that you can do some shopping even before you reached office, right? So isn't that something that we've always dreamt of, to have inexpensive door-to-door transportation service? We all know in India, we have a lot of accidents, leads to fatalities. And would it be ideal if suppose you had some way to get warned if there was an impending chance of a collision? Maybe you could avoid accidents. Maybe you could avoid fatalities altogether, right? So in the earlier example, you had a car which was taking a left turn and you had to warn the pedestrian saying, be careful while crossing the road. There is a vehicle that's going to turn left. And in the second example, you had the bicyclist being told there is a speeding truck, right? Watch out for the speeding truck. So these are examples. And a final example that I want to present is about the road infrastructure, right? So suppose we have a car that's equipped with these kind of accelerometers, and a smaller version of these accelerometers are there in the smartphones that we all use day to day, right? If this is placed inside a car, and as the car moves along a pavement, a road surface, it's going to be able to pick up the tiny, we can call vibrations that the vehicle is experiencing. And we could use that data to understand what's happening in terms of the pavement quality, right? Maybe there are a few spots where you see that kind of bump in the road. And over time, if you're not attending to those, they could turn out to be potholes. And we know what happens as a result, right? So can we identify these kind of problems in the pavement even before they occur? So that's a question that perhaps some of you may have asked at some point, right? So what we are talking about here is all the questions that you saw earlier, all the examples that you saw earlier, we can address them using connected vehicle technologies, right? So this looks like a large intersection that we typically come across in cities. But assume many of the vehicles that you see here are actually equipped with some kind of devices to communicate. Right? They may be communicating with each other, the vehicles may communicate with each other, or they may be communicating with roadside equipment, maybe the traffic signal controller, or perhaps even the pedestrian who's walking on the road, or the bicyclist that you see at the bottom here. So these technologies can be broadly divided into vehicle-to-vehicle communication technologies, vehicle-to-infrastructure communication technologies, vehicle-to-pedestrian communication technologies, and pedestrian-to-infrastructure communication technologies. So these technologies can revolutionize how we travel. For example, if you have V2V, vehicle-to-vehicle communication technologies, you could get instantaneous travel time information on the entire network. You can make more optimal decisions in terms of which routes you want to take. You could also get information like the time to collision. If a vehicle in front of you has slowed down and you're not able to see the vehicle for some reason, right? That information is passed on to you and you're able to react just that fraction of a second ahead of what you would normally do, and as a result, avert collisions. You could have buses communicating to traffic signal controllers informing, just hold the green light for a little longer so that I can cross the intersection, right, comfortably. So this is called bus signal priority. So this can be enabled using vehicle to infrastructure communication. You could have maybe the pedestrian who's crossing the road over here, right? He is getting information from the car that you see in the lower left over here, saying, I'm going to take a right turn, right? I will watch out for you. You also watch out for me, right? So that we don't end up in a conflict, right? You could also have a pedestrian perhaps who's crossing the road communicate with the traffic signal controller saying, just hold the green for a little longer while I safely cross the road. Right? So all of these could make the way we travel on our roads, the way we interact with other travelers, other vehicles, and improve our level of service, as we call it. So the core of our lab is going to look at connected transport. I want to make it more general than connected vehicles because we're talking not only about vehicles, we're talking about pedestrians, bicyclists, maybe public transit systems, right? The controllers and so on, right? So this will be the core of what we want to look at in this center. And within this connected transport realm, we want to explore three, maybe distinct, but definitely interrelated areas. One is traffic flow and control. How do connected vehicles navigate in a traffic stream? How does the navigation occur when it's mixed traffic? When you have some of them as connected, some of them as not connected, what happens? Understanding those kind of phenomena will be one objective. The second objective would be to understand how traveler behavior changes as a result of all these connected technologies. And also how driving behavior changes as a result of connected transportation, right? Again, just like in traffic flow, you may have some of the vehicles which are connected, others are not, right? In such a scenario, how would you as a driver behave? That's a very interesting question that we need answers for. We also want to understand and maybe collect data from these connected vehicles to better understand how the pavement and geometric conditions impact traffic flow and how traffic flow impacts the pavement and geometric conditions, right? So in a way, there is interaction among all these three realms. And we want to explore these three realms by looking at multiple performance measures. For example, how are we doing in terms of efficiency? How are we doing in terms of sustainability? Right? Is safety and health being improved of the road users? Are we able to use all this technology to better manage our infrastructure? Right? So these are related questions that we seek to answer when we talk about connected transport. This slide kind of gives a very quick pipeline of what we want to achieve as part of this lab. That is going to be the 3 M's and the 4 M's and the E, right? We have monitor, measure, model, manage, and evaluate. So monitor is about getting the infrastructure in place. the sensors that we require, right? We're going to look at three major infrastructures that we hope to set up as part of the center. One is a test bed, which is a real life test bed. We equip them with sensors. We equip it with sensors in the vehicle as well as in the infrastructure. I'll talk about that. Then we hope to set up a driving traffic simulator, right? A driving simulator through which we can collect data in the lab, right? Driving data in the lab. There could be experiments which we cannot conduct in the real world. So those experiments we conduct in the lab, collect data, better understand, and then come up with optimal decisions, which could then be tested in the real world. And then we also hope to set up a test track. So just like I said, in the real world, we may not be able to do all the experiments, especially new technologies may not be possible to test in the real world. So the test track will kind of serve as a platform where we will be testing out such new technologies. And then we will be measuring a whole set of data that we'll be measuring to get a whole set of data, right? Data related to connected technologies, right? Data related to the infrastructure, the geometry, the roughness conditions, maybe some kind of side friction that we experience. Right? We'll also collect data on traffic flow, the composition, right? So all of this data is going to be measured. And one of the key differentiating aspects that we believe we bring to the table is looking at all of this from the perspective of heterogeneous traffic conditions, which is prevalent in a country like India. Right? We have heterogeneous traffic conditions, and we also have a mix of users, right? Users who behave very differently under similar scenarios, right? So we hope to capture some of the heterogeneity in behavior as well using these infrastructure and the data that we collect, right? Eventually, we want to move towards modeling, which is our strong point, right? And use the models to be able to better manage, right? In terms of the performance measures and the impact assessment that we talked about earlier, efficient mobility, sustainable mobility, safety and health, and infrastructure asset management. Eventually, we want to put all of this together and develop a kind of a decision support system that cities and the country as a whole can use so that we can make more optimal decisions going forward in terms of our transport infrastructure. So I'll briefly talk about the infrastructure and perhaps some of the research questions that we will address. The first one is, of course, the test bed. So this is going to be a real-world test bed, right? We are going to equip it with multiple sensors, onboard units in buses, roadside units, Wi-Fi sensors at mid-blocks collecting data of Wi-Fi devices which pass through. We can use this data to also get information on travel times, routes that people take, right? Condition information, and so on. Right? We also hope to equip some of the vehicles with LiDAR sensors, maybe IMU sensors, and use this data to better understand driving behavior. Right? So some of the inertial measurement unit sensors as well to better understand how people drive. And this is not independent of the traffic in which you're driving, right? So you collect data about the environment as well, right? Perhaps using these kind of LiDARs. And we correlate how you drive in relationship with the traffic that is around you. We also propose to set up this test track. So this would be a completely instrumented 1.5 kilometer long test track. We hope it will be set up in the new campus that we are building at Thayu, which is about 30 kilometers on the OMR road in South Chennai. And this test track will serve as a test bed for new technologies, right? Whether you talk about connected vehicles, even autonomous vehicles, electric vehicles, right? We hope this test bed will be used to test out before these can be rolled out in the real world. And we would be equipping this test track with advanced sensors. So this will also serve as a test bed for these kind of advanced sensors to better understand their capabilities. And we hope to collect very rich data about driver behavior, about the vehicular response, traffic flow, right? And as well as the interaction between these with the roadway, both geometric as well as pavement conditions. This would be a unique facility, we believe, once this is set up in the country. And then the simulator, this is the third infrastructure that we want to set up. So we would have a network of simulators. So it is not just going to be a single simulator, but we want to have a network of them over a period of 3 to 4 years. And this enables us to understand how they users can interact with each other, right, and get more realistic simulator results, right? So we also hope to integrate the simulators with virtual reality so that there's a much more immersive environment, so that the transferability of results that you measure in the simulator lab is easier when it comes to real world. And we'll also integrate these simulators with biosensors to collect high fidelity data, physiological data of the respondents. So some of the research questions that we hope to answer is using the instrumented vehicles that we are going to set up and collecting data on our test bed. We hope to have very high fidelity trajectory data for connected vehicles. And using these, we hope to perhaps solve multiple problems, right? For example, understanding where traffic congestions are happening, how traffic congestion evolves, how it materializes, right? Being able to identify even before it starts materializing and taking remedial actions, using it for perhaps giving feedback on autonomous driving, using it for dynamic traffic light control, as well as applications like signal priority for buses. Right? So these would be some applications and models that we develop in the traffic operations realm. Similarly, in the public transportation as well as in the transportation planning realm, we hope to collect data from surveys, right, both stated preference as well as revealed preference data, and also look at new ways of collecting data. Right, how can we use data that people reveal through apps, through their smartphone use, and so on, as well as data from the public transit agencies, such as ticketing data, right? And in an ongoing project, we're looking at data from a couple of different cities so that you have much more diversity in the data set. We can better understand what works and what doesn't across cities, right? All of this data, this is big data. We talk about big networks cluster. This is big data, right? We're talking about several lakhs of records being generated every day, right? So this is going to be requiring sophisticated analytics tools, statistical models, machine learning models to better understand the travel behavior. And these would then be used to inform policy makers, right? Based on the travel behavior we infer, based on the mobility solutions that can be offered, we will be able to give policy makers suggestions about how to influence travel behavior, how to nudge people towards a certain behavior that's much more optimal for a system, right? And the focus is going to be on emerging technologies like mobility as a service, electric vehicles, and also more optimal public transit systems, more responsive public transit systems. So these are some applications and research questions we hope to deal with when it comes to transport planning. And we already saw how we could be using accelerometers to collect data. We could get information about linear accelerations, angular accelerations, right? Again, this could be generating huge data sets. How can we make sense of all of this data to be able to come up with models on urban pavement deterioration, right? We ask the question, how can we find out if a pavement is going to fail even before it fails? So those kind of questions as well, we hope to answer here, right? And some of these would then feed into other models, right? Such as a pavement distress prediction model, and as well as models on traffic state estimation, emissions estimation, and so on, right? So eventually, like I mentioned, we would be looking at integrating all of these models, all of this data, all of this behavior, the pavement, vehicles, traffic, they interact with each other. All of these we want to integrate into a decision support system, right? And this tool is something that we will make available for policymakers, for transport planners, so that they can make more informed decisions when they have to come up with some guidelines, right? Think about alternative scenarios or answer what if questions. So I talked about multiple aspects. This kind of summarizes some of those aspects, right? So we have multi-scale, multimodal, behavioral transportation science theory as our foundation. We collect data, we build models, we design algorithms, we develop this kind of integrated decision support tools. But this is not where we stop. We want to further build on this, right? We want to look at specific applications that we can develop and make it available for the public to use. We want to be involved in drafting specifications and guidelines at the national level, right? We also want to incubate, startups that can, innovate new technologies and solutions that make our transport much more seamless, right, and easier. And while doing this, we want to focus on both academic publications, be one of the top research universities in the world, and at the same time contribute to the society in the country, right? And all of this is a very dynamic process. There are multi-way interactions across these different blocks that we have drawn, and we want to be geared towards this big picture over the next 3 to 5 years. I'll just conclude with a couple of slides that talks about what would be some of the other contributions that we hope to make. We would like to have several international conferences so that we bring in the best of ideas from across the globe, right? We also want to look at coming up with educational programs, international programs. We want to kick off a master's and a PhD program, right? We want to also introduce some summer schools and summer internship programs for international students so that we have a flavor of international issues as well when we research some of these problems. We also would like to come up with monographs, which could be books that people refer to when they have to talk about connected technologies and they have to talk about data science applications in transportation. And finally, we want to have a much more broader impact in terms of manpower trained, in terms of data sets generated, in terms of researches published, and so on. Right? We hope to collaborate across academia, industry, as well as user agencies. So data is something that's common across these, but we want to go beyond that. We want to get problem statements from user agencies so that the research we do is relevant. We want to take the help of industry so that the technology we develop can be utilized in the real world. And of course, with academia, we want to deepen and broaden our collaborations across the world. So these are the core faculty. We have perhaps about another 15 faculty from other departments at IIT Madras. I couldn't fit all their pictures in here, but some of them are here in the audience. We are thankful to them. And these are some international collaborations that we have built over the years. We want to strengthen these, and at the same time, we want to explore newer collaborations going forward. So with that, I will end my presentation. And yeah.
So awesome presentation, Dr. Gita. What I would, I just looking at the attendance here, you got well over 100 people on just on the Zoom. One of in the chat, I guess I'll just remind people on the Q&A, please enter that in. I see the Q&A questions are coming in. Maybe I'll start out with maybe a fun one. Maybe Gita, if you could reshare your screen and put that picture of the motorcycle simulator up there.
Yeah.
One of the questions came in, and I think it's first of all, my comment is you put up the motorcycle simulator.
Sure.
I want to see. At some point I want to get a chance to try it, or at least get a picture of you, or at least get a picture of you there on the right hand side.
Yeah. But I mean, we're excited. Yeah.
One of the questions came in about the autonomous two-wheelers. I thought sometimes we blend connected and autonomous together, and I guess I thought that was a good segue for maybe just highlight the importance of first studying connected vehicles to inform autonomous. So maybe over to you on that, because I think particularly in the Indian environment where you have a very heterogeneous environment, broad connectivity is important. So over to you.
Yeah, I mean, I think it's a fascinating question, right? When we talk about autonomous vehicles, we talk about cars in particular, right? Or perhaps we talk about trucks, right? I have not come across, research in two-wheelers as autonomous vehicles, right? But definitely, that's definitely an area of research. One of our, core collaborators, Professor Shankaram, has done a lot of research on two-wheeler dynamics, right? So I think that's definitely a rich area of research. And one of the things perhaps I want to highlight here is when we talk about autonomous vehicles, it's not, we're not talking about level 5 autonomy from day one, right? So there are different levels of autonomy, and so it would be interesting to see at what level we could introduce autonomy in two-wheelers, right? Maybe there could be some level of guidance to start with, right? Maybe there could be some kind of electronic balance of the two-wheelers if suppose a two-wheeler is losing balance, right? So those could be initial steps before perhaps we reach full autonomy. Having said that, I don't know which two-wheeler rider would like to, give control away. Right, part of the thrill of riding two-wheelers is to have full control.
Right.
That's just
My perspective is I think there's some opportunity for, I think connected two-wheelers, if you put up your slide where you had trajectories on there, as you were talking, and I think I would be fascinated to see, I think particularly in that heterogeneous environment in India, and it's not just two-wheelers and cars, but several types of vehicles, but we've never really been able to look at that vehicle dynamic. So I would argue you laid out a really good framework that connecting to the two-wheelers before, not necessarily making them autonomous, just connecting to them presents a whole host of opportunities for understanding the network, and probably more importantly, identifying opportunities to improve the safety. So
completely agree. Maybe I can request, Professor Bhargava or Lalita to, share their thoughts.
Lalita?
Yeah, sorry, my mic didn't work. Yes, as you correctly pointed out, it's in a very basic level we are starting. We may not have the full trajectory level information of all the vehicles in the beginning. That's where more research will be involved in terms of building the trajectories or filling up the information from what's available to us. It's impossible to have 100% penetration of connected vehicles. So the extra challenge or the biggest challenge for us may be in terms of how do we fill up the information and come out with a good estimation and prediction so that it will be ready to be implemented in the field. That I see as a biggest challenge, in fact, yes. And the connected vehicles, yes, we are planning to have at least, two-wheelers with enough sensors running in the field, collect data to see how they move, because the way in which two-wheelers move is completely different from how cars or trucks will move. So that will be another interesting modeling challenge for us. How do we finally come out with, equations that can capture this movement, and how do we... So there are enough interesting, exciting, challenging problems, though this is an area which is already there in other countries, well developed or much ahead. But we have our own peculiar problems which we have to handle, and that's where the excitement is. That's where the challenge is.
Excellent answer, or excellent commentary. So we got a couple questions here that are kind of grouped. I would when I think about computer vision, I think about it in terms of the traditional way was the RGB images where you can see, and then in this slide up here, Gita, you've got a LiDAR sensor on it, and I've been a huge proponent of LiDAR, but there are also varying opinions out there on cost and applicability. I guess I'd like to hear your thoughts on how you or other colleagues on this call see that ecosystem evolving of LiDAR and RGB research.
So, in fact, one of the things that we hope to, procure is multiple types of LiDAR systems to see how well they work in Indian conditions, right? But I'm not very familiar with how LiDAR can be used in the context of RGB. Maybe you need to enlighten us a little bit there. But I think, we have to look at sensor fusion. We have to see how some of these can complement each other, right? Maybe the camera system could complement the LiDAR. And, one of the other technologies that we've been exploring is also the millimeter wave radars, right? So those are known to have certain advantages with, which perhaps the LiDAR systems don't have, right? So how can we perhaps compare these and, more importantly, complement some of these technologies, right? So that's going to be something that we hope to explore as part of some of our research studies.
Very well stated. So as I think about your test track there and the alternative technologies, it's definitely a sensor fusion problem, and I think that opportunity of pulling those together, and the test track gives an opportunity for students to get some of that hands-on experience. So outstanding. So I know I tend to be very technology heavy, but we also have a question coming in here kind of on the AI aspect on reinforcement learning for network level. So maybe we've talked a little bit about sensing. Maybe you can kind of give us a sense on how you see that team forming on the AI type aspect, and who else you might want to. Feel free to loop in others on the colleague, right? I don't want you to feel like you're the gentleman being cross-examined, right?
Sure. So, I mean, I think, one of the interesting aspects of, research ecosystem at IIT Madras is there are multiple research groups. For example, we have a research group on data science and artificial intelligence, right? And so we interact very closely with them, right? And we have some reinforcement learning gurus, right, who are sitting in that center as well, with whom we collaborate closely, right? I think he's in the audience, but perhaps, I'm not able to get his opinion in today. But yes, looking at network level impacts of how RL agents interact and how the system evolves, I think that's an emerging area of research, right? Many of even RL, when it's used for signal control, what I've seen is they kind of do it at isolated intersections or at the minimum interaction between 2 or 3 signals. But how does it work when you have a network, right? I think these are still open questions. So as much as technology is something that where we need to innovate, I think there is scope for innovation and research on also these analysis tools, right? The data modeling aspects, and definitely that is a rich source of research going forward.
Just to add to that, can I?
Yeah, over to you, Lisa.
Yeah. Since there were multiple questions where AI will be useful or machine learning will be useful, I can see that can be applicable to almost all the different areas that we talked about. For example, large amount of data. So most of the big data analysis, we may need some kind of machine learning and things like that. Image processing, LiDAR data processing. So each of these involve multiple levels of machine learning, AI, all those coming in. So, but that having said that, that's not the only approach we will be using for analyzing the data or developing models. We definitely will be interested in traditional, more theoretical models that can capture these in equation forms, for example, where we will be able to interpret more in terms of why it's happening or what exactly is happening. But the large data definitely gives us that extra edge. We can use always data driven techniques too. So there is enough scope, enough opportunities to apply both traditional methods as well as advanced techniques.
Very good. Lisa, you mentioned big data, and I think you've been a leader for a decade on kind of the big data on the buses. I hope you guys are going to scale that maybe by even another order of magnitude, right? I mean, as we hear about this test track and so on, I can imagine just an even richer data repository out there for your students.
We hope so. We definitely will have much more data.
Super. So there's a couple questions coming in here with regard to ambulances and emergency vehicles. And I guess I'd pose this on 2 fronts, right? Let's just focus on the connection. And I think we really want to view this as a 2-way problem: communication from the ambulances or emergency vehicles, and communication too. So maybe, could you maybe make some comments on what you see some of those early tests and evaluations being done, either in the live stream or on your test track?
So maybe I'll request my colleagues to talk about the signal priority problem that they're working on, right? So, Professor Bhargava or Professor Lalitha?
I was hoping Dr. Bhargava will be talking. Yeah, so we are actually working on signal priority, not particularly for emergency vehicles, but we were looking at more from public transport, bus priority, which is a more challenging problem. The emergency vehicle priority being, stop everything and allow vehicles to go, the emergency vehicles to go, versus we are looking more for bus priority, where we don't guarantee all the time priority, But if it improves the situation, if it reduces the delay, overall delay, we will give priority. And to enable that, we need V2I communication. So we are using DSRC, for example, as the communication. As the bus is closer to the intersection, they start communicating. We have algorithms doing. So the same thing we can definitely apply for emergency vehicle priority, because signals are where the maximum delay happens. So we will be able to apply these priority algorithms that we are developing for emergency vehicles too.
Outstanding. So
Yeah.
maybe just I'm sorry, I cut it over you, Bhargava.
Yeah, so if I may add, this is Bhargava. So I think, as you rightly pointed out, what was Lalita was mentioning is about giving information to the, or responding to the ambulance. I think we can also give information to the ambulance, like in terms of routing within the network. So how do you get the person from where he needs to go, right? Given that where he's located, so we can give information to the ambulance about the shortest path in the network. And then the next part would be when they come to the intersections, we'll give priority and let the vehicle go. So I think that's something, it can happen both ways, both giving to the information to the ambulance as well as taking it from the ambulance.
I think that's a key point, right? It's a two-way, and I guess Lalita, you made a comment about DSRC, and this has been a very fast evolving area in the United States. I mean, V to X now seems to be our latest term. I've yet to X continues to evolve on a daily basis, but I guess my comment would be, as this evolves, Gita had a nice slide up there. Maybe you put it up there, Gita, in terms of industry and academia. That collaboration was a really, and to me, is going to be a critical part. So maybe if you could, maybe that one right there, that's perfect. How do you see getting that ecosystem? We talked about this a little bit beforehand. How do we get that ecosystem together with industry so that we're helping shape some of those decisions? Because I think you guys, through your test bed, will have some very good insights on that. So jump ball question off to Bhargava, Lalita, and Gita on that.
Yeah, maybe I'll start off and then I'll pass it on to the colleagues. So I think, yeah, the key is, when we talk about these kind of technologies, we've seen that, I think 30 years back, when we talk about intelligent transportation, it was clearly in the realm of the governments, right? The government agencies were responsible for that. What we've seen in the past decade is just about all ITS has moved from the government to the public, to the private industry, right? So I think if you're talking about connected intelligent transport systems, it cannot happen without the industry being on board, right? We need to work closely with them, right? And so the test track is definitely a place where we seek, collaborations. We hope some of the industry would be open and willing to partner with us in testing some of the technologies in this test track, right? So that's one of the objectives of the test track. So yeah, if others want to add to that, yeah.
Yeah, I agree completely. And along with that, one of the key groups is the car manufacturers, because the connected vehicle itself is not there out in the market. So we definitely need industry support from the car manufacturers for us to, acquire, run it, test it, modify it, all those. So we are definitely in touch with, and many other industry partners too. But this, I thought, particularly is very relevant at this point, because there are no connected cars available, with all the features that we are talking about out in the market.
Agree, and I think okay, over to you, Bhargava.
Yes, and one other aspect that we're going to look at is how do you transfer this technology that we will be developing, the algorithms, models, and so the solutions that we develop. So we cannot package it and market it, right? So I think it has to be useful to the public, and industry partner is required. So we'll also be looking at transferring the technologies to the industries so that can be used for public good.
Agree. So I guess I'm an incredibly strong, enthusiastic supporter of involving industry and research, and Lalita and team, anything I can do to help in that space, because this is a worldwide problem, right? We don't want to have, we got to kind of come up with a consensus type approach. So I think the path you guys are going down is fantastic. Maybe pivot just a little bit here on the questions. We got one coming in here about climate and weather. And if you remember, Lalitha, as Alex and Steve were over there during some really heavy rains, and we did some of the early Bluetooth one. Rain, you don't have a lot of snow, but precipitation has a large impact on both driver behavior and sensor behavior. So maybe make some comments on how you see environmental impact on the connected and autonomous ecosystem being evaluated. Did I lose you?
Yeah. So I think, I agree, right? So part of the idea of having the test bed is to be able to detect or, to observe the performance of these sensors in the real world, right? And so that's one thing. And the other thing that, we want to highlight is the test track is also going to be equipped with a lot of these advanced sensors. And to a limited extent, at least, we should be able to mimic different scenarios, right? Say, for example, how does a LiDAR work when you have rain, right? Maybe we could artificially create rain in a stretch of the test track and subject the LiDAR to different tests, right? Maybe we could create artificial smoke if we get permissions for generating that. I don't know how it works, in India yet, but yes. So we could maybe put it to test in the test track, right? So that's a possibility, and I think these are important questions. The other thing also is the traffic environment in itself, right? So in India, we have a highly heterogeneous, very dense traffic, right? In such scenarios, how do these sensors work? I think that's also going to be interesting. And we hope the test bed and the test track will give us data, will give us sufficient variations so that we can make some inferences about the impact of these on the sensors and perhaps consequences.
Great response. So I'm trying to make sure in the interest of kind of making sure that we finish on time. My understanding is the next session starts in about 1 minute. So
yes,
I want to just thank the speakers, the Q&A from Bhargava, Lalitha, and Geeta, as well as you guys had amazing audience participation. I did not get through all the questions. I didn't even get a chance to ask my pre-canned question. So Geeta, you obviously did a great job stimulating discussion, and the rest of the panel, you guys function as an awesome team. So thank you for letting me host this. And I look forward to seeing all of you guys in person sometime in 2022.
Thank you very much, Professor Dasi. Indeed, to say it was a very good session and moderated well. And we have received such a quality question, and the quality answers were provided by our professors. So I may kindly request everyone, the participant, to also participate in the next webinar under the same cluster. The webinar is on network systems learning, control, and evaluation. So you can use the same link tree to register for the ongoing webinar. Thank you once again for the participation. Looking forward to meet you in the next webinar. I mean, the ongoing webinar. Thank you. Thank you very much.
Thank you. Thank you, Darcy.
Thank you.
Thank you.
Yeah.
Thank you.
Bye.
Thanks to all for joining. Bye.
Ms. Ujjola, please proceed for the closure. Thank you, Ujjola.
Thank you. Thank you, sir.